find points of inflection for a given function, we need to know when does the second derivative equal 0. Test for concavity. To find the second derivative, I might want to rewrite the first derivative as a polynomial in descending order instead of trying to use some form of the product rule for these three factors. So I multiplied this all together and got this as another form for f prime. I took the derivative of each term and got negative 3x squared plus 30x plus 37. And we want to know when that equals 0, for which I used the quadratic formula, because I was pretty sure it wasn't going to factor. And the number that I got under the radical is this 1,344. And here I'm showing like kind of what I did on my scrap paper to find out what the simplest radical form for 1344 was. 1344 is actually 2 to the 6 times 21. The square root of 2 to the 6 is 2 cubed. That's where I got this 8. And I decided to divide negative 6 into negative 30 and get 5 plus or minus 4 radical 3 over 21. These are we think are going to be the x-coordinates of the points of inflection. On a calculator, I found out that these correspond to about negative 1.11 and 11.11. So we want to put those two, what we used to call hypercritical numbers, on a number line and find out what the sign of the second derivative is. So we pick a test number. A number to the left of negative 1.11, for example, would be negative 2. So what's f double prime of negative 2? Well, if I put negative 2 into the second derivative, I'll get negative 3 times 4 is 12 minus 60 plus 36. That's a negative number. That's all we care about. And when the second derivative is negative, I think frown face, the original function is concave down. For f double prime of 0, which would be a test number in this interval, we get, well, that's easy, 37, which is positive. So concave upward. And finally, to the right of 11.11, what's f double prime of 12, for example? If you put 12 into the second derivative, you will find that you get a positive number. I mean, a negative number, sorry. So we put a negative here, concave downward. Since the concavity changes at these points, these are points of inflection. So the x-coordinate of the first point of inflection is 5 minus 4/3 radical 21. We don't know what the y-coordinate is because we don't know what f is. We could find an antiderivative for f prime, but we wouldn't know what the plus c value was. So we really can't find the y-coordinate of the point of inflection, but the x-coordinate of the second point of inflection is 5 plus 4/3 radical 21. Now we could have different forms for that answer. I could have left this like this and said negative, I could divide top and bottom by 2 and get negative 15 plus or minus 4 radical 21 over negative 3. But there you go. Hope that helped. If you have any questions, post a comment.